Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework that we have for lesson 3.2.5. Starting off with M&Ms, the basic idea here is the term multiplicative inverse is a fancy way of saying reciprocal. So when do we use the multiplicative inverse or reciprocals? Well, this is a process that is helpful when we are learning about dividing fractions. So what is a reciprocal? Well, if you take a fraction and you reverse the order of the numerator and denominator, you have created the inverse or the reciprocal. And how you know that they are multiplicative inverses of each other or reciprocals of each other is that when you multiply the two reciprocal fractions together, you always get the answer of 1. So 8 over 5 times 5 over 8 becomes 40 over 40, which is a giant 1. If you take a mixed number, it can be rewritten as a fraction. And so that fraction will have a reciprocal. You won't write a reciprocal for the mixed number. It wouldn't really make much sense because you've got a whole number there. So you got to put it in a fractional form, and then you can multiply it times its reciprocal, and you will get a giant 1 for an answer of 1. Okay, and even whole numbers do have reciprocals because any whole number can be written as a fraction with a denominator of 1. So 7, ooh, I don't like that. Let me change that to this. 7, actually this, would be the same as 7 over 1 times its reciprocal, which is 1 over 7, is how you're going to get your giant 1 of 7 over 7, which is going to be equal to 1. Okay, so we'll be putting these reciprocals into use when we are dividing fractions. So describe or simplify each expression without using a calculator. For each expression, draw a diagram or use words to explain how you know your answer makes sense. Not crazy about drawing the diagrams here, but really, here's the question I always like to ask. When you're doing division, how many of these can you fit into here? In other words, what would you multiply times -4 to give you -8 for an answer? So it turns out you can fit 2 of these -4s into -8. And if I were to draw this kind of a diagram, let me change colors here. If I draw this kind of a diagram, you have -8, 1, 2, 3, 4, 5, 6, 7, 8. Those are 8 perfectly drawn negative signs, right? Sorry, my OCD. Boom, boom. Okay, that's better. So how many -4s can you get out of that? Well, there's one -4, and there's another -4. So you can pick 2 of them. So that's your answer. If you take +18, this is where things start to get a little bit clunky, but I'll try and show it. 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, how many -3s can you fit into that? Well, there aren't any, right? Because they're all positives. But if you change them to their opposites, you could get 6 of them, right? So if we start by thinking, all right, if we just broke these 18 positives into 3 equal parts, or in groupings of 3, you would have a total of 6 of them. But we want them to be the opposite. We want them to be -3, so we would have to change that to -6. I know. I mean, it doesn't really work the same, but you know, this does work. What do you multiply times -3 to give you +18 for an answer? Well, 3 times 6 is 18, and since that's a negative, you'd have to multiply a negative times a negative to get a positive answer. So that's how our answer is -6. Same thing here. What do you multiply times 2 to give you -24? Well, 12 times 2 is 24, so you'd have to take -12 times 2 to give you -24. And then the same thing applies here. So, you know, drawing diagrams sometimes is nice, and other times it almost makes things a little bit more confusing, I think. All right, all the order of operations, which would be ruled by PEMDAS. Or you could circle the terms if you want to do that. Let's try it on this one. You see that plus sign? Remember, the terms are the parts that are getting added together. So you could take the -7 plus whatever the answer is to 4 divided by -2. So that is -7 plus -2. Now, if you did PEMDAS, the order of operations, you would have had to do the division first anyway. So circling the terms really didn't do anything different than what you would have done if you had followed PEMDAS. Here you've got the same kind of idea. You're doing division here first, then you add, I guess you would do this division and this multiplication. Just do them separately, because you've got to find out the answer to this multiplication problem. You've got to find out the answer to this division problem before you can add those two together, since addition and subtraction have the lowest priority. So what is 17.5 divided by -7? I don't know what that, no, I'm not doing that. I'm doing this. I'm going to take 17.5 and divide it by 7, and then change my answer to a negative, since it's a positive divided by negative will give me a negative answer. So we know that's going to be -2.5, and then -8.1 times 2, if you double that, becomes -16.2. And so now you add those together, you got, wait, what have I done here? Have I made a mistake? I think this is another one of those mistakes, because that's a negative and that's a negative, right? So that means our answer, we should be adding these together, not doing a subtraction. Very, very interesting. So once again, this might have been one of those situations where I was trying to catch some snoozing students to see if they would notice my mistake. That can't be right. The answer's got to be -18.7. And maybe I just didn't close that 3 into an 8. Not sure, but I'm going to leave it there for next year to see if students catch that mistake. All right, here you have to do what's inside the parentheses first. So 8 plus a -3 gives you 5. And then when you multiply 5 times -5 3/5, we will have to change both of these into fractions and then multiply the numerator times numerator and denominator times denominator, unless you understand that you could take 5 times -5 and then 5 times 3/5. That would actually work too, but let's not go there. Let's just do this. 5 over 1 times -28 over 5, and now you can cross cancel the 5s and you get -28 as your answer. And then here, what do we have to do? 4 minus a -3 is the same as 4 plus a +3, so that's going to become a 7. And then 5 divided by -5 ends up giving you -1. So 7 plus -1 gives you 6 for an answer. Read the math notes in this lesson and write the reciprocal for each one of these numbers. So you're just flipping them upside down, right? 2, remember, it could be 2 over 1, so that's why the reciprocal is 1/2. And then 2 and 5/8 is 16. 21 over 8, so the reciprocal is 8 over 21. Check your answers by multiplying and the given number with your answer. So remember, when you multiply two numbers that are reciprocals together, you get a giant 1 for your answer every single time. If you don't get a giant 1, you have not, no, it's right here. You have not identified the reciprocal. So all of those work. Write at least 3 expressions that use these numbers, 2, 3, 6, and 8, only once in any operations and grouping symbols. Each expression should have a different value, with one of them being equal to 28. All right, so I started off by figuring out what combination of operations I use with these numbers that would get me to 28. So 3 times 8 is 24, 24 plus 6 is 30, and 30 minus 2 is 28. But now when I start changing the order around, or had I even chosen to use parentheses, I could have changed the overall value of that expression. And there are tons of different combinations that you could use, so these are just two that I chose. For problem number 86, here we are working with reciprocals and the inverse property. Is this the inverse property or the identity property? I think it's a combination of both. The inverse property of multiplication says when you multiply a number times its opposite, you get 1 for an answer. That's what we're talking about. Okay. The identity property would be if you multiply a number times 1, your answer stays the same. That's not what's happening here. So write this as its reciprocal. The product is 1. Write 31 over 27 as its reciprocal. The product is 1. And then if this is 5 times 2 in the numerator to give you 10, then you're going to have to do 2 times 5 in the denominator to give you 10 as well. So each problem is a pair of fractions whose product is 1. They're all reciprocals of each other. And that concludes our homework for lesson 3.2.5. Let's move on to the next activity. Take care. Bye. Bye.
Hey, feeling good, like I should. When in dark